Hi guys, welcome back. This is part 2 of our automatic temperature control project with Flowcode. In part 1 we designed the circuit diagram. In this part 2 we're gonna start with the code. Start a new project. We're gonna use the PIC 18F45K22. We're gonna use 80 MHz external crystal oscillator. So we're gonna select medium power 4 to 16 MHz. We're gonna disable the PLL, we're not gonna use it. We're gonna disable the watchdog timer. Okay. The first thing we're gonna add the component that we're gonna use. We're gonna need an LCD. We're gonna use the 16:2 generic LCD A23D. We're gonna need a keypad. We're gonna use the 3x4 keypad A23D. We're gonna need 2 relays. If you don't know where to find the component that you're looking for, you can search it. Search for relay. Okay, we're gonna use this one, A23D. A relay is basically a controlled digital device capable of switching much higher voltages and current than the normal microcontroller output pins. The output pin of a PIC microcontroller generally limits you to about 25 milliamp. If you want to switch higher voltages and current, such as to control a heater or a fan, like in this example, then we're gonna need a relay. We're gonna need a second relay. And lastly, we're gonna need an analog sensor. That the input, we're gonna use this potentiometer. This will allow analog values to be read on an ADC pin of a PIC microcontroller. The next thing we need to specify to which pins of a PIC microcontroller we're gonna connect our devices. From the circuit diagram, the LCD will be connected to port C, the keypad to port B, the analog sensor is gonna be connected to analog 0, which is on RA0. The heater relay will be connected to RT0, and the fan relay will be connected to RT1. Gonna start with the LCD. Data 0 is gonna be connected to RC0. Data 1, RC1. Data 2, RC2. Data 3, RC3. The register select is gonna be connected to RC4, and the enable pin is gonna be connected to RC5. The keypad custom pins, we're gonna connect column 1 to RB0, column 2 to RB1, column 3 to RB2, and the rows will be connected to RB4, 5, 6, and 7. The first relay, let us rename it so that we're not gonna confuse it with the second relay. We're gonna name it relay heater, and we're gonna connect it to RD0. The second relay, we're gonna also name it relay fan, and we're gonna connect it to RD1. Lastly, we're gonna connect our analog sensor to analog channel 0, which is gonna be on RA0, and we're gonna rename it LM35. The VREF gonna be 100. Okay, the first thing, we're gonna display a welcome message on our LCD. We're gonna display automatic temperature control. So let us initialize our LCD display. Start. When we start our project, we're gonna switch off the heater and we're gonna switch off the fan. Heater, switch off. And the fan, we're gonna switch it off as well. LCD cursor, gonna start our message, position 4. Gonna display on the first line of the LCD. Print string, automatic, and on the second line let's switch to the second line first. Temp control. Gonna display this message for 2 seconds. Okay, let us run. Automatic temp control. So far so good. After 2 seconds, we're gonna clear our screen, then prompt the user to enter the reference temperature. LCD clear. Then gonna prompt the user to enter the reference temperature. Print string, enter temp ref, press the H key to end. Okay, because we are using a 16 by 2 line LCD display, it can only display 16 characters per line, and enter temp reference, press H key to end is more than 16 characters. So we're gonna display the first part of the 16, then we're gonna scroll the screen to display the remaining part. So the first part is gonna be displayed, let's say for 2 seconds. I think it's gonna be enough to read. Then we're gonna scroll the display to the left so that we can see the remaining part of the message. Scroll display, we're gonna scroll it by 16 position, and the direction is gonna be to the left. Left is 0 and right is 1. 0. And this part of the message, we're gonna leave it on the screen for 2 seconds. Then we're gonna scroll back to the original position. LCD scroll 16 position. There's gonna be 1. Then move the cursor to the second line. Second line, we're gonna display temp ref. LCD print screen, temp ref. So the next thing, we need to read the value of the reference temperature from the keypad. Gonna need a loop. In this project, we're gonna accept a reference temperature of up to 2 digits, so it's gonna display from 0 to 99. So we're gonna need to loop until we've got 2 digits, or if the enter key has been pressed. So I'm gonna need 2 variables. One is gonna hold the reference temperature, and the other one is gonna count until we've got 2 digits. Me declare those 2 variables and initialize them to 0. And the first one, we're gonna name it count, and it's gonna be a byte variable. The second one, we're gonna name it ref temp. It's gonna also be a byte variable. gonna be 0. Gonna initialize it to 0, and the count variable we're gonna initialize it to 0 as well. I'm gonna loop until 2 digit or the hash key has been pressed. We're gonna test our loop at the end. So while count is less than 2 and key, the key is gonna be a variable that is gonna hold the number that we're gonna press. So let me declare a new variable. We're gonna name it key. It's gonna be also a byte variable, while key is not equals to 11. When you press the keypad, the star key is gonna return the numerical value of 10, and the hash key is gonna return the numerical value of 11. Okay, so we're gonna read our keypad read and get the number, and we're gonna store this number in key. Then we're gonna check if this number if key is less than 10, it means we have pressed any digit beside the star or the hash key. Just write a comment here, add new digit, ref temperature is gonna be equals to ref temperature times 10 plus key. We're gonna also increment the value of count. Count is gonna be equals to count plus 1. Shift the cursor then we're gonna display the key pressed. Gonna print number, reference temperature. We must also wait until the key is released. So here we're gonna wait for key to be released so that we can only consider one key pressed. Gonna need a loop. We're gonna remain in this loop until the key is released. Once you release the key and no other key is pressed, the value of the key is gonna be 255. So we're gonna remain in this loop while the key is not 255. Get number, return key. Once we are done, we're gonna clear the screen. Then we're gonna display the value of our reference temperature and prompt the user to continue. Tempref print number, tempref, second line, press the H key to continue. Then we're gonna wait until the H key is pressed. So while key is not equals to 11. Keypad, get number, and return key. Then we're gonna clear the screen. Okay, let's run our project again. Automatic temp control, enter temp ref, scroll, press H to continue. Gonna enter 13. Temp ref equals to 13, press H key to continue. Wonderful. As you can see, our flow chart is getting longer and longer. And if you want to set up our reference temperature while the project is running, then we'll have to write again the same piece of code. So the easiest way is to use a macro. A macro is basically a section of code that can be used and reused in a project. Macros allow complex tasks to be handled by code blocks, and they can be imported and exported. A macro can basically be considered like a function in C language. Instead of writing the same code over and over again, you can just write it once and call that function when needed. This is the icon of a macro. We're gonna create a new macro. We're gonna name it setup temp ref, add new, setup temp ref. So we're gonna cut this section of the code and paste it inside our macro so that we can be able to call it whenever we want. Cut, Control V. Okay, now we're gonna call this setup temp ref macro. We're gonna start reading our temperature. So we're gonna create a new macro. We're gonna name it read temperature, add new. We're gonna read the analog voltage, LM35 get voltage, and the return value we're gonna store it in a float variable. So let us declare a new float variable. New, we're gonna name it analog value. It's gonna be a floating point variable. Then we're gonna convert this analog value to temperature. We're gonna need another variable. We're gonna name it temperature. It's gonna be also a floating point variable. Temperature gonna be equals to use the mathematical function to multiply two floating point variables. Analog value, we're gonna multiply it with 500. This because the output of a LM35 is 10 millivolt per degree Celsius. We're gonna need another string variable. We're gonna name it temperature string, and the size of this array is gonna be 4. It's gonna be a string. Then we'll have to convert this floating point variable into string. These are string manipulation functions. Float to string, temperature. LCD cursor, then we're gonna display temp ref on the first line of LCD. Temp ref display number, gonna display the reference temperature, and on the second line we're gonna display the current temperature. Cursor, print string, print string. Then we're gonna display the degree symbol, print ASCII 223. Different LCD displays have different character code for the degree symbol, so you must check your data sheet for more information. And lastly, we're gonna display the C character. Print string C. Let's run again. Automatic temp control. The reference temperature is gonna be 26. Enter. And this display on the first line temp ref goes to 26, and the current temperature at the moment is 0. I can change it. Okay, the simulation ended because you must always not allow your main loop to exit. So I'm gonna create a while one loop. Okay, we need to read continuously our temperature, so we're gonna insert our read macro inside the while one loop. Let us run. The reference temperature, we're gonna set it to 29, and now it's displaying the current temperature to be 149 and the reference temperature 29. So I can change the temperature. Okay. The last thing in this project, we need to compare the temperatures so that we can decide whether to switch on the heater or to switch on the fan. We're gonna need another macro. We're gonna name it compare temp. Here we're gonna have a if statement. If the reference temperature is greater than the current temperature, then we're gonna switch on the heater and switch off the fan. Heater switch on, and the fan we're gonna switch it off. We're gonna decide again if the reference temperature is the same as the current temperature. We're gonna switch off everything. The fan is gonna be off, and the heater is gonna be off as well. And lastly, if the reference temperature is below the current temperature, then we're gonna switch off the heater and switch on the fan. Heater is gonna be off and the fan is gonna be on. Okay, let us run. Set it to 28. The reference temperature is greater than the current temperature, so the heater is on. Now increase the current temperature, then the fan is on and the heater is off. Let us save our project. Save. Automatic temp control. Gonna compile it to X so that we can be able to load it into a PIC microcontroller. Okay, the compilation was not successful. It returned some errors in the configuration. It says the PIC18 extended instruction set was enabled but is not supported by this compiler. And the configuration section is gonna be the 4th configuration. Okay, let us go to build project options. The 4th group, extended instruction, we're gonna disable it. Save, compile again. Compilation successful. Let us simulate in Proteus as well. Run. Automatic temp control. Enter the reference temperature. We're gonna enter 27. Continue. Okay, you can see the reference temperature is 27 and the current temperature is 27.3. So the fan is rotating to cool off the area. If I can decrease the temperature, you can see the heater is also switched on. Increase again and the fan is switched on. And that's all guys for this tutorial. In part 3, we're gonna add the EEPROM to this project to store the reference temperature so that each time you switch on your application, you don't have to enter a new reference temperature. It can just read it from the EEPROM. We're gonna also enable the setup menu in operation, so while you press and hold the star key, it's gonna prompt you again to change the reference temperature. We can also see what other features that we can use to improve this program. Thank you guys for watching this tutorial. Don't forget to subscribe to this YouTube channel to receive more tutorials in the future. And if you've got any comment, you are welcome to leave any comment. We promise you that we always reply to each and every comment. And I will see you guys in the 3rd part. Thank you.